Okay. Hi, everybody. A very good morning. I hope you're all doing great. Okay. So we have only 4 of you, right? Maybe we'll just wait for 1 more minute so that your friends join, and then we'll start right away. Right. I made the host. Yeah, I'm the host. Okay. Okay, I think I can start. Let me share my screen. So people, we have been seeing this. We started last class, if you remember, and we saw what are all the different types of carbon compounds we can have, right? Okay, so we said that these compounds of carbon are what are called as functional groups, right? So the simplest of them all is what is called as hydrocarbons, right? So from the name itself, you can realize that there is going to be only carbon and hydrogen along with them, right? There is no other element present, only carbon and hydrogen, right? So people, we have to be very careful in writing any of the compound, not only hydrocarbons, any of the compound. If you want to write, you have to make sure that all the carbons will have 4 bonds, right? All the carbons will have 4 bonds. You have to be very careful, right? Like you should not have more than 4, you should not have less than 4, exactly 4, because carbon is tetravalent. Okay, fine. So we said that the hydrocarbons can be classified into 2 types: aliphatic hydrocarbons and alicyclic hydrocarbons. Aliphatic hydrocarbons are straight chain compounds, right? Say whatever you saw, for example, this one is actually going to be an example for a straight chain compound, right? Okay, and alicyclic hydrocarbons are going to be ring structures that it is not going to be in our syllabus for now, right? So don't worry about it. Okay, so this aliphatic straight chain compounds can be again classified into 2 types. One are what are called as saturated, the other one is what is called as unsaturated, right? So saturated compounds will have only C single bond Cs. There is no double bond, there is no triple bond, right? But in unsaturated, we are going to have C double bond C as well as C triple bond Cs, right? Okay, whenever we have C double bond Cs, those kind of compounds are what are called as alkanes. And when you have C double bond Cs, they're going to be called as alkenes. And C triple bond Cs, if you have, they're going to be called as alkynes. And there are going to be compounds where you will have both double bond Cs as well as triple bond Cs, right? So those again, the compound name is going to be again alkyne only. Even if you have both of them, C double bond C as well as C triple bond C, it is going to be called as an alkyne. Okay, right. So we understand that, see, these are the different examples. You just have to understand that every carbon atom should have 4 bonds with them, right? If at all something is missing, put hydrogen. That's it. We saw all these things. Alkyne we saw, alkene we saw, right? So second class of compounds are what are your halogen compounds, right? Along with your carbon and hydrogen, you are also going to have one halogen present. What are halogens? These 4 elements: fluorine, chlorine, bromine, and iodine, right? So you are going to have either a CF bond, CCl bond, CBr bond, CI bond. Any of these is going to be present. And examples are like this, right? Along with, you just replace one of the hydrogen from the hydrocarbon with your fluorine or any other halogen for that matter, right? So those are about halogen compounds. Then we can have alcohols. Alcohols are very famous. Ethanol are used in beverages and stuff, right? So here we are going to have one carbon having an oxygen, and that is going to have a hydrogen. COH bond should be there, right? So COH will be there. Obviously, other 3 can be anything. The other 3 bonds I mentioned here can be anything. In shortcut, you can just represent it as COH. Very simple, right? So you have some structures like this: CH3, CH2OH, ethanol, all these things, right? Okay. Next, we have something called as aldehydes or ketones, right? So aldehyde or ketone is going to have this particular thing common: C double bond O common, right? So you're going to have a C double bond O. Obviously, for this carbon, 2 bonds are already over, so 2 more bonds should be there, right? And I told you the carbon atom containing the oxygen is this double bond is what is called as carbonyl carbon, and the oxygen is what is called as carbonyl oxygen. Okay, right? So now how do you differentiate between aldehyde and the ketone? To the carbonyl carbon, you should have a hydrogen attached, right? Not to any other carbon people, to the carbon atom having oxygen, C double bond O, you should have a hydrogen attached to it, then it has become an aldehyde, right? So example you can see, right? The carbon atom having double bond O is having H and H, so it's going to be an aldehyde again, right? So this time, both sides you have hydrogen, right? You can have only one side hydrogen, other side carbon, like this. Again, these carbon, again, tetravalence should be satisfied, right? Okay, so that is an aldehyde, right? Now, what about ketone? Now you have to understand that in ketone, there should be a C double bond O, and other two bonds should be carbon atoms, right? Other two bonds should be carbon atoms. You understand? Say C double bond O is there, carbon, carbon. Again, all the other bonds should be satisfied, right? And you can just represent this structure like this: CH3, C double bond O, CH3, like this, right? So we saw more examples, right? Both, again, you see C double bond O is there, both side carbon. Again, it is going to be a ketone. All right, fine. And then we saw about carboxylic acids. Okay, now carboxylic acids are going to have this structure. They're going to have a C double bond O, right? And along with the C double bond O, they're going to have one OH. So they can represent it like this: COOH, right? The actual structure is going to look like this: C double bond O with the OH, and obviously 1, 2, 3, 3 bonds satisfied. One more bond should come. Okay, right? So again, you can have so very different varieties of acids coming, carboxylic acids coming into the picture, right? So then I gave you introduction. To the IUPAC naming, right? I know what is IUPAC, International Union of Pure and Applied Chemistry. Okay, right? And I told you that IUPAC name consists of 3 parts. One is what is called as prefix, the other one is what is called as root word, and the other one is what is called as suffix. Okay, right? So we will now move on. We'll just see what are these prefixes, what are root words, what are suffixes, right? How do you write them? What are the different ways to write prefix, suffix? Everything we'll understand now. Okay, right? Any questions anybody has till now regarding the functional groups? What are the different functional groups? Any questions anybody has? Okay, fine. So people, so please understand that whenever you write the IUPAC name, this is the order with which you write. First prefix should come, then the root word should come, then only the suffix should come. Okay, be very careful, right? First prefix, then the root word, then the suffix. All right, fine. So people, now there are going to be certain rules, right, which you have to follow for your IUPAC name. Rules for IUPAC name, right? The first rule which you have to follow is you are going to identify the longest possible chain. Okay, right? The first step in IUPAC naming is that you are going to identify the longest possible chain. So what I'm trying to tell you, right? Say if I give you a structure like this: CH3, CH2, CH2, CH3, CH2, 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 CH3, CH3, something like this. Okay. So obviously you have to start with one carbon atom and end with another carbon atom. Right? Now you have to make sure that you're going to identify the longest possible chain. Right? Now you want, for example, if you check this one, right? Say I can tell there are 1, 2, 3, 4, 5 carbon atoms. Okay, if you go this way, right? If you just check this way, right? In this chain, there are going to be 5 carbon atoms. Okay, right? Is it correct, people? What our writing is correct here? Or is there any other way by which you'll be able to get more number of carbon atoms? Yes, no?
Sir, the chain below the 4th one, sir.
Okay, so there's another possibility, right? So if we use some other color. Right. So I can start with this carbon and end with this carbon. How? 1, 2, 3, 4, 5, 6, 7 I'm getting. Okay. So this side, if you go, I'm getting only 5. But this, if I take, I'm getting 7 carbon atoms. So obviously 7 carbon atoms only is correct because I identify the longest possible chain. Not some possible chain. You have to identify the longest possible chain. right? So this side, if you go, I'm getting only 5 carbon atoms, but if I take from this, you're getting 7 carbon atoms, right? So you have to be very careful in choosing the longest possible chain. This is the first step. Okay, identifying the longest possible chain. Okay, in most of the compounds, it is going to be very straightforward. Okay, very straightforward. Right? In this case, I just gave you the most toughest one. Right? So you can easily identify that you are going to be 7, not 5. Right? Okay, fine. So people, second point. Right? Once you identify the longest possible chain, what are you going to do? You are going to give numbers. You're going to give numbers to the carbon atoms in the longest possible chain. In the longest possible chain. Okay, that you already did. You can understand, right? You understand that you're already giving numbers 1, 2, 3, 4, 5, 6, 7 like this. You have to give numbers to the carbon atoms that are there in the longest possible chain. So basically, this and this will not have any numbers now. Right? Only for the carbon atoms that are there in the longest possible chain, only to those carbon atoms you give some numbers. Okay? To no other carbon atom. Obviously, this carbon atom is extra, this carbon atom is extra. We'll see what are you going to do about it. Don't worry. Okay, you have to first identify the longest possible chain, and you are going to give numbers to the carbon atoms that they're only and only in the longest possible chain, right? And the numbering should not be chumma random, right? So you have to make sure that you have to give numbers to the longest possible chain such that the most prioritized functional group should get the least possible number. Least possible number. Okay, this is very important point, such that the most prioritized functional group should get the least possible number. Okay, so you cannot randomly number it. Okay, you must keep in mind that the highest prioritized functional group, like I'll tell you what you mean by priority. Functional group, we know what is functional group, right? So if at all you have more than one functional group, or say only one functional group is there, you have to make sure that that particular functional group, whichever carbon atom having the functional group, should get the lowest possible number, least possible number. Okay, let me give you some examples, right? Say I have CH3, CH2, CH double bond CH2. I have this compound. Okay, so here the functional group is double bond. Is it not? Here the functional group is double bond. Okay, now there can be two ways of numbering here. One is 1, 2, 3, 4. The other possibility is you can start from here, right? There is no restriction. I have to start only from here. I can even start from here also. So 1, 2, 3, 4. There's two possibilities. Okay, now I said that the functional group here is double bond. Okay, so the carbon atom containing the double bond should get the least possible number, right? So if you go this way, you are getting 3 for the carbon atom having double bond. Least number I'm talking about. Obviously 3 and 4, but you're getting only 3. That's the least possible number. Okay, but if I go from here to here, what am I getting? I'm getting the carbon atom having double bond at 1 itself. Right? So this is the correct way. This is wrong. Right? We have to be very careful. Yeah, this is the longest possible chain. Longest possible chain contains 4 carbon atoms. No doubt about it. Right? And we are going to have the numbering now. How are we going to number? We are going to number the carbon atoms in such a way that the most prioritized functional group, in this case, the most prioritized functional group is double bond. Okay. Now that particular functional group should get the least possible number. So the upper part, the black one, is not correct because you're getting 3, right? But if you go from this side to this side, you're getting 1. So you have to choose the lowest possible number. So this is what is correct. The lower one is what is correct. I hope everybody understands, right? Say another example. I'll give you. Yeah. Yes. Tell me, Kanna.
No, sir, I understood.
Understood. Very good. Okay. Say I'll give you another example. Say we have CH3, CH2. Not CH2. Okay, fine. Let's give it as CH, OH, CH2, CH2, CH3. Something like this we have. Okay. Now in this case, the functional group present is OH. right? So you have to make sure that the carbon atom containing the OH should get least possible number. Okay, fine. Let us try both sides. Okay, say if I mark 1, okay, obviously you have to start with just because you want to get the lowest possible number, you cannot put 1 here. That doesn't make sense, right? You have to start from the ending, right? Okay, so we have 1, 2, 3, 4, 5. So 5 carbon atoms longest possible chain, and the carbon atom containing the functional group is having 2. Okay, we'll check the other possibility, right? Other possibility can be say 1, 2, 3, 4, 5. Right now, what are we getting? The carbon atom containing the OH, that is a functional group, I'm getting 4. Obviously, that is incorrect. 2 is only correct. So the upper part is only correct. The lower part is wrong. Okay, right? Fine. Now, see, there might be some difficulties if at all you have more than one functional group, right? More than one functional group you can have. For example, say, look into this. Say we have CH3, CHCl, CH double bond CH2. Okay, now what you have? You have two functional groups. One is double bond, the other one is Cl. Two functional groups are there. Okay, now you have to, that is why this particular word, most prioritized, right? It's not about having functional group. If at all you have more than one functional group people, you have to look into the priority. Let me tell you how you have to choose the priority or not, right? So now if at all you have more than one functional group, we have to understand that whichever is having maximum priority, that should get the least possible number. Okay, now please understand in this case, double bond, C double bond C and chlorine, if you check, C double bond C has more priority. Okay, I'll give you the entire list. Don't worry about it. For now, you have to understand that the C double bond C will get, has more priority than Cl. Okay, right. So in this case, where you have to start numbering, obviously you have to start numbering from here. 1, 2, 3, 4, because this is the maximum priority functional group, right? And that should get the least possible number, right? If you go for the other one, let's say if you go for 1, 2, 3, 4, right? You are getting 3 for the maximum prioritized functional group. That is C double bond C is the maximum priority. If you go from this side to this side, you are getting 3. That is wrong, right? But if you go from this side to this side, the maximum priority functional group is this C double bond C. I'm getting at 1 itself. So this is only correct. Okay, right? So be very, very careful. Okay, right. So I have to give you the priority order. Okay, I have to give you the priority order now. Let me give you the priority order, right? So see, in this case, you have only 2 functional groups. What if I have 10 functional groups, 20 functional groups, something, right? See, or let me tell you one more thing also. See, now look at this. If you have CH3, CH or CH2 double bond CH and okay, CHCl, CH2, CH double bond CH2. Okay, right. Now what are we seeing? We are having 2 double bonds. One double bond here, another double bond here. 2 double bonds we have. Okay, and we have 1 chlorine also. Right now, whether it's 1 or 2 or 3, whatever it is, we understand that double bond is going to have more priority. That is understood. Okay, so let us check what is happening now. Right, so let me put the numbering. Say 1, 2, 3, 4, 5, 6. 6 carbon atoms I'm getting. Chlorine should not be counted in the carbon atom. Please be very careful. This is Cl. Right? Okay, this is one possibility. And we are getting what numbers for double bond we'll check. Okay, so for double bond, I'm getting 1. Okay, and for the second double bond, I'm getting 5. Okay, and for the chlorine, I'm getting 3. Okay, right, fine. Next, let us look on the other side. 1, 2, 3, 4, 5, 6. Okay, right. Now you understand. I will check what numbers are getting for double bond. 1, double bond you're getting, and again at 5, we are getting a double bond. Okay, so last time also 1, 5 double bond was there. This time also 1, 5 double bond was there. Isn't it? Right? So that means however you number, either you go from this side to this side or you go from this side to this side, the maximum prioritized functional group, that is your double bond in this case, is coming out as 1 and 5 and 1 and 5. Okay, right. Then what you have to do? Then you have to look in the second priority. right? If the maximum prioritized functional group are having same numbers, however you number the carbon atoms, right? Then in those cases, you have to look into the second prioritized functional group. That is in this case Cl. Okay, in this case, I'm getting 1, 5 and 1, 5, right? So what you have to do is you have to look at the second priority. Second priority is Cl. Now that also has to get the least possible number. Okay, that also has to get the least possible number. So if I go from here to here, we are getting 3 for chlorine. But if I go from here to here, we're getting what? We are getting 4 for chlorine. So obviously this one is wrong. This one is correct. Because I'm getting 3, lowest possible number, 4, little higher. So only have to do the least possible number, that is 3. Okay, right? So again, I repeat, people, however you go for this compound, for the maximum prioritized functional group, you are getting 1 and 5 and 1 and 5. Right? So in these kind of cases, if the maximum prioritized functional group is having same number, however you go for numbering, right? Then you have to look in the second priority. Second priority in this case is Cl, and that also has to get the least possible number. So top one, if you go, I'm getting 3. Bottom side, if you do from this side to this side, I'm getting 4. So 3 is only correct. So the top one is correct. The bottom one is wrong. I hope you're following. I hope everybody is following. Right? Okay. Fine. So we understand that these kind of possibilities are there. Okay. Okay. Right. So now I'm going to give you the priority order. Priority order of functional groups. See, there is no logic here, people. Okay. This priority order, whatever I'm going to give you, does not have any logical reasoning behind it. It is just given by IUPAC. Okay, to avoid confusion, because so many people will have different opinions. Okay, so IUPAC said, what you just follow whatever I say. That's what IUPAC said. So this priority order is given by IUPAC. Okay, right. So priority order of functional groups. Right, and you have to remember this. Right, you have to remember this. All right, fine. So people. So first is hydrogen. Obviously, hydrogen is going to have the least priority. Least priority. Okay. Then, if at all, you can have branch, right? Branch like say CH3, something like this. Okay. Okay. Then you can have say C2H5, right? Higher number of carbon atoms will have higher priority. Okay. Then comes fluorine, then chlorine, then bromine. Then iodine. Okay, right? Next, after this comes C triple bond C. Right? When you have the C triple bond C, that is going to have more priority. And look at this very carefully. C double bond C has more priority than C triple bond C. Be very, very careful. Right? C triple bond C has more priority compared to C double bond C. Okay, right. So after C double bond C, then comes alcohol, OH, right? And then after alcohol comes your ketones, right? Then comes aldehydes, right? And the maximum priority of them all will be having by carboxylic acids, COOH. Okay, so this priority order we have to remember. There is no logic, but we have to remember this for IUPAC naming. If you do not remember this, you will not be able to give the names. Okay, so this is the priority order, and we have to remember this. All right. Okay. Right. So we understood, if at all I have more than one functional group which has to get more priority, and whichever is having more priority will have the lowest possible number. Okay. Fine. Cool. So that is about the second point. Right. Okay. Third and final point. Third point in the IUPAC naming is that if there are more than one prefix, we don't know what is prefix yet, don't worry about it. Okay, so if there are more than one prefix or secondary suffix, we don't know what is suffix first of all. So again, suffix can be of two types. Coming to that point, don't worry about it for now. Okay, so if there are more than one prefix or secondary suffixes, right, right, alphabetical order has to be followed. Alphabetical order has to be followed while writing their names. by writing their names, right? Say for example, right? Say in a compound you have two prefixes. One is methyl and the other one is hydroxy. Do not worry about what are these for now. Okay, fine. So there is a compound in which there are two prefixes. One is methyl, another one is hydroxy. So you will write hydroxy first, then you will go for your methyl group first. So basically you'll write hydroxy and then methyl you will write in the IUPAC name, and then whatever the name, whatever it comes, you will write it. Okay, right? So this is the thing. All right, fine, people. This you don't, because you don't know what is prefix and secondary suffix is. Like all that you have to understand is whenever you write something, you have to follow alphabetical order for some prefixes and secondary suffixes. Okay, fine. Now, people, going back to this thing, going back to the parts. Okay, right? Let me write the parts again for you. Right. So any IUPAC name, right? Any IUPAC name, I told you, will contain three parts. One is what is called as pre. Pre means before. Prefix, before the root word. Okay, right. And after the root word comes suffix. Okay. And what you have to understand is suffix can be of two types. One is what is called as a primary suffix, right? Primary suffix. And then what we have second, what we have is called as secondary suffix. Okay, right. Now I'll tell you the exact order in which you will write the IUPAC name. So IUPAC name will be equal to the prefix part plus the root word plus the secondary suffix. First I'll write the secondary suffix and then you have to write the primary suffix. Okay, this is the exact order in which you should write. You should not write suffix first, secondary word, or something. No, this is the order. Prefix first, then root word, then secondary suffix, then your primary suffix. Okay, right? This order we must understand. Okay, right. So each and every part of the IUPAC name, that is prefix, root word, secondary suffix, and primary suffixes, are actually going to give you different informations about the compound. Okay, right. So this prefix, right? Prefix talks about less priorized functional groups. Less priorized functional group. Okay, so we understand, right? In the compound, we can have more than one functional group, right? So one will have more priority, the others will have lesser priorities, right? So the prefix gives you information about the less priorized functional groups. Okay, say for example, in this compound, right? So we have a double bond and you have a Cl, right? So you will write Cl as a prefix because that is having lesser priority. Okay, you will write Cl as prefix because that is going to have lesser priority. Be very careful. Okay, because double bond is having more priority, that will not come in the prefix, but whichever is having lesser priority, that will come in the prefix part. Okay, and that is what is told by this one. Right, prefix talk gives information about less priorized functional groups. Okay, fine. What does root word tell you? Root word tells you about the number of carbon atoms in the longest possible chain. In the longest possible chain. Right? We understand, right? We gave numbers. We understood how many carbon atoms are there. Say in this case, 4 carbon atoms are there. In this case, 5 carbon atoms are there. In some other case, 7 carbon atoms might be there. Right? So the root word gives information about how many carbon atoms are there in the longest possible chain. Obviously, only in the longest possible chain. Okay, right. So root words are constant. Okay, how is it constant? Say if at all we have only one carbon atom totally. In the longest possible chain, we have only one carbon atom, right? The root word which we have to use is meth. Okay, the root word which you have to use is meth. Okay, second, if at all you have only 2 carbon atoms in the longest possible chain, right? Then you will use eth as a root word. 3, if you have, then you have to go for pro. Okay, right? So 3 carbon atoms in the longest possible chain, then you'll use the root word as pro. 4, if you have, it is going to be bute. Okay, 4 if you have, it is going to be bute. Okay, then if you have 5 carbon atoms in the longest possible chain, then it is going to be, the root word is going to be pent, P-E-N-T. Okay, 6 carbon atoms in the longest possible chain, hex. 7 carbon atoms the longest possible chain, hept. 8 carbon atoms the longest possible chain, oct. 9 carbon atoms, dec. No, non. NON. Okay, and 10 carbon atoms in the longest possible chain, you will go for dec. Okay, again, these numbers and the corresponding root words you have to remember. 1 means met, 2 means het, 3 means prop, 4 means good, 5 means spent, 6 means hex, 7 means hept, 8 oct, 9 non, and 10 is dec. More, we have more than 10 also, 11, 12 also we have names, but for your level, don't worry about it. Okay, till 10 at least you have to remember. Okay, right. Fine. So, and people, I want to know what are the deleted portions in this, in your carbon and compounds chapter. What are the deleted portions? Do you know?
Sir, we
Sir?
have covalent bonding in carbon compounds, versatile nature of carbon, and homologous series. Sir. Only these three are included.
Homologous, that's it. Nothing else is included.
No, sir. In the portions, they have just given homologous series.
So they did not teach you IUPAC naming in the school?
In school,
Did
they
they
are taught, sir.
Okay. Fine. No issues. Okay. Right. We'll just see then the little what to say. We'll not go so much depth into this because that is not there in the syllabus. IUPAC naming is not there in the syllabus for you. Okay. Fine. No issues. Right. So we understand, right? We, depending on the number of carbon atom, the longest possible chain, you will give all these things. Okay. Right. And coming to this secondary suffix. Okay, now secondary suffix indicates whether we have C single bond Cs or C double bond Cs or whether we have C triple bond Cs in the compound. Okay, that is what it indicates. Okay, whether we have C single bond Cs only or whether we have any C double bond C or is there any C triple bond C, then that is indicated by your secondary suffix part. Okay, very important. Right, fine. And it's very easy to understand also. You can just give the name also. Say, for example, if you have only C single bond Cs in the compound, right? If you have only C single bond Cs in the compound, the secondary suffix which you'll use is AN. Okay, secondary suffix you'll use is AN. Okay, and when you have C triple bond Cs, you will write the secondary suffix as EN. Right, and when you have C triple bond Cs, you will write the names as YN. That's it. Okay, these three are the only possibilities. Okay, C double bond C means, sorry, C single bond C means AN, C double bond C means EN, C triple bond C means you will write YN as the secondary suffixes. Okay, right. Now coming to the last one, the primary suffix. Right, the primary suffix. Now that is going to give you the information about the most prioritized functional group. Most prioritized functional group. Okay, so people, what are you understanding? If at all you have more than one functional group, say 10 functional groups if you have, for example, right? Out of them, only one of them will have maximum priority. Is it not? Only one of them will have the maximum priority. Correct. So for the one which has the maximum priority, you have to write the suffix part, primary suffix. For all the other 9 which are going to have lesser priority, for all the other 9 things, you have to go for prefix. Again, I repeat, if you have 10 functional groups, obviously one of them will have maximum priority, and the one which has maximum priority will be written on the suffix part, primary suffix part. Right, and all the other 9 which are going to have lesser priorities, right, all of them will come in the prefix part. So you'll have 9 prefixes. That is why we say when you have more than one prefix, you have to go for alphabetical order. So in this case, you see one primary suffix is there. Obviously, in every compound, only one primary suffix will be there. Only one, because there'll be only one maximum priority. Right, and all the others are going to have lesser priority is going to come under prefix part. Okay. right? So these are all the things. These are all the different parts explaining different things in the IUPAC name. Prefix talks about less prioritized functional group. Root word talks about the number of carbon atoms in the longest possible chain. According to that number, we'll have different root words. Okay. Now secondary suffix talks about whether we have any double bond, triple bonds, just a single bonds. Whether you have double bond, I mean single bond means AN, double bond means EN, triple bond means YN. Okay. And then the last primary suffix is going to give information about the most prioritized functional groups. Okay, right. So now what we have now, the only thing which we have to know now is what for a particular functional group, right? What are the prefixes? What are the suffixes? Right. See, for example, there are going to be certain functional groups which will have both prefix as well as suffixes, depending on whether that is going to be higher priority or lesser priority. Right, in a particular compound, if that compound is that particular functional group has the maximum priority, then no doubt go for the suffix. But in some other compound, that particular functional group will be there with some other functional group. Like for example, say if at all you have only C double bond Cs, right? Only C double bond Cs, then that is the most prioritized functional groups. Okay, but what if you have C double bond C along with OH? In that case, you have to treat your C double bond C as prefix and your OH as primary suffix. Hope you understand what I'm trying to say. So the same functional group can have prefix, can have suffix, depending on what compound are you talking about. Right? Okay, fine. So I'm going to give you one. Okay, right. So I'm going to give you one table. Okay, right. So the table is functional group. What are the different functional groups? The prefix, how will you write the prefix and the suffix? Okay, right. Say you have the functional group to be alkane. We know what are alkenes, right? We're just going to have only C single bond Cs, nothing else. Hydrocarbon only with C single bond Cs, right? Those are what are called as alkanes, right? So if at all you have to use alkanes as prefix part, right? That means along with alkane, say you have an OH or C or something like that, then obviously for the alkyl group in alkene, you have to use a prefix, right? So in that case, you will use alkyl. That is the name which you will give, right? So if at all in the branch you have only one carbon atom, then you'll write it as methyl. 2 carbon atoms, ethyl. 3 carbon atoms, propyl. Like that. Number of carbon atoms, you know how it varies now. Right? And the suffix, if at all there is only alkane present and that's the maximum prioritized functional group, then you will end up with the suffix should be ANE. ANE. Right? Say people, it's very easy to understand. Look at this. Now, for example, we have this is the most simplest of all hydrocarbons, CH4. Right? CH4 we have. Now, obviously, you understand that there is only one carbon atom in the longest possible chain. So the root word is meth. There is no prefix here because there is no other functional group. Okay, so we have the most prioritized functional group to be this only. So the root word, now there is only one carbon atom, so it is meth, only one, right? And I know it is an alkane because there are no C double bond Cs or single bond Cs. So what you have to end up with is ane. Okay, what you have to end up with is ane. So methane is the answer to this question, right? That's the name of the compound. Say for example, if you have CH3, okay, then how do you write it? You understand that there are 2 carbon atoms in the chain and there are only C single bond Cs. So definitely it has to end with ANE because it is going to be an alkane, right? And how many carbon atoms are there? 2 carbon atoms are there. So that is going to be called as the overall should be eth because there are 2 carbon atoms. And since it is an alkane, you have to end up with ANE. Ethane is the name of the compound. Right? Same way, say if at all I have 3 carbon atoms like this. Right? I understand that 3 carbon atom means the root word is prop, right? And I understand that there are only C single bond Cs, no other thing is there. So you have to end up with ane, so prop, ane. That's it. That's how you give the name. Okay, right. Fine. So next one is about alkenes. Right? Alkenes, when you know what are alkenes? When you have C triple bond C, C double bond Cs, right? So the prefix will be very rarely using, but still I'll just let you know it is alkyne, right? And the suffix you have to end up with is ene. Okay, right. Next, if you go for alkynes, right, that would be having C triple bond Cs. So the prefix which you will use is alkynyl, right? And the suffix which you have to use is Y and E. Okay, right. Next, say for next, if you have Cl. Now, first let's start with fluorine. If you have fluorine as the functional group, then remember that for fluorine there is no actually, let me say, fine, for fluorine there is no suffix. You have to have only prefix part, right? So you'll write it as fluoro. For chlorine, it is chloro. Prefix, suffix is not there. Okay, then bromine, for that bromo, no suffix, right? And for iodine, iodo, no suffix. Okay, then comes OH, that is your alcohol, right? So for alcohol, prefix is hydroxy, right? And the suffix which you have to use is ON, right? Next, going to your aldehyde, right? Aldehyde, fine, you will write methanol for prefix, and the suffix it has to end with al, aldehyde al. Okay, and then if you have ketones, right? Ketones don't, okay, fine. So it is generally going to be okay. Ketones, you should write oxo or keto as the prefix, right? And if you want to write the suffix, then that is going to be ONE or ON. Okay, and at last carboxylic acids, COOH. If you have, there is no prefix because that is the maximum priority functional group. There is no way that it can be a prefix, but suffix is oic acid. The suffix is oic acid. Okay, right? So these are all the different prefixes and suffixes for all the different functional groups. Okay, it might be given in a textbook also. Right? It is given in a textbook also. You can go through that. Okay, right. And people, I thought like IUPAC naming is there. That's why we spend so much time on this. Okay, but since it is not there, we'll just consider homologous series only. Okay, right. So people, what, like if not you're interested, right? If you're interested, once we complete the portions, once we complete the portion of periodic table also, maybe I will take some, maybe I'll take some 2 to 3 classes for you to know how to name the compounds also. It's very interesting. Okay, very interesting. Okay, but now that it is not there in the syllabus, we don't have to worry about it. Okay, right, fine. So people, what do you mean by homologous series? Okay, so people, homologous series is nothing, right? Say you start, for example, we have alkane. We have your alkane is going to have only C single bond Cs. Okay, right. So homologous series is the next compound which can come. That is, if you remove one hydrogen, I have one compound, I have one alkane, say for example CH4. Okay, we have your CH4. Okay, right. So in the CH4, if I just replace this hydrogen with a carbon, H. Now I have replaced this hydrogen with a carbon. Right, now again tetravalent should be satisfied, so you'll get another H like this. Okay, now what I do in this compound, I replace this hydrogen with another carbon. So in that case, you will get H, C, H. Now instead of this hydrogen, put a carbon. Again, the tetravalent should be satisfied. Like this, you will get. Okay, so homologous series means I have the same family of compound. Homologous series, same family. Alkane is the family. Okay, in the same family, from the compound, I replace one hydrogen with a carbon. I replace the one hydrogen with carbon. I keep on doing like this. This entire series of compounds you get, this is what is called as your homologous series. This is what is called as your homologous series. Okay, and let me tell you one more point. For alkanes, there is a general formula. For alkanes, there is a general formula, and the general formula is CnH2n plus 2, where n is an integer. Okay, n is an integer. For example, let me put n is equal to 1. Okay, if you put n is equal to 1, what do you get? C1, okay, 2 into 1 is 1. When 2 into 1 is 2, plus 2 will become 4. So C1H4, or I can just write it as CH4. This is nothing but your methane. This is methane, right? This is ethane. This is propane. Next will be butane, pentane, hexane, like that. It can keep on going. Okay. Now say when I put N is equal to 2, what will you get? You'll get C2, right? 2 into 2 will become 4. 4 plus 2 will become 6. C2H6. This is nothing but ethane. Right? So how will you write this? CH3, CH3. That is your ethane. Like that, you will be from the basic formula, from the general formula. If we just keep on increasing the N value, again, what you will be getting is the homologous series. Okay, so how can I give a proper definition for homologous series? Homologous series means a family of compounds, right? Which is having, how to put it, family of compounds. Okay, which is having different number of carbon atoms, right? And I can say that one compound will be derived by replacing another, by replacing one of the hydrogen in the previous compound. So I have the shortest one, right? You take one hydrogen and replace with carbon, the next one. Again, you have the second shortest one. You take the hydrogen, replace with carbon, the third one. Like that, you'll be able to form the homologous series. Okay, right? So that's about alkanes general formula, CnH2n plus 2, right? So for alkenes, the general formula is CnH2n. CnH2n. So you can easily understand. For now, remember that for alkenes, N cannot be equal to 1. N should start with 2, 3, 4 like this only. Why? Because for alkenes, we need a C double bond C. If I have only one carbon, how can I make a double bond? With what will you make a double bond? That doesn't make sense at all, right? So minimum of 2 carbon atom is required for me to make an alkene. Okay, right? So we can have, say, CH2 double bond CH2. Now I can check the formula, right? So if I put N is equal to 2, if I put, I will get C2H4. I can see C1, C2, H2, H4, C2, H4. Okay, I replace one of the hydrogens here. I will be getting, say, CH2, CH, CH3, something like this. This is your ethane. So not ethane, ethene. This is ethene. This is going to be propene. Like this, you'll be able to see. Okay, and at last, what about alkynes? Right, alkynes are going to have CnH2n minus 2. That's the general formula, right? So again, N should start with 2 only, because we are going to have a C triple bond C. Minimum of 2 carbon atoms are required, right? Okay, so you are going to have, say, for example, CH triple bond CH. Now put N is equal to 2, right? If you put N is equal to 2, you'll get C2, right? 2 into 2 is 2 minus, 2 into 2 is 4, minus 2 is 2. Again, C2H2. Again, you see C2H2. Like this, will be able to get. This is your ethyne, right? Then I can just replace this hydrogen with another carbon. If I do that, CH, another carbon I put. I have a triple bond here. Okay, and for that, again, you have to supply 3 hydrogens, right? So you can write this one as CH triple bond C, CH3. Now this is going to become propyne. Okay, so this ethyne, propane, again, are homologous series. Again, ethene, propene, butene, all those are homologous series. Again, methane, ethane, propane, pentane, like that, continuously going. Those are again called as homologous series. Okay, so this is nothing but a homologous series. Okay, the same one compound is derived from another compound by replacing the hydrogen with a carbon. Very, very simple, right? The entire series you're going to get is what is called as homologous series. Okay, right? So with this, the chapter is over. Okay, and we still have the IUPAC naming left, but that is not there in your syllabus, but we will take it up. Okay, once we complete the syllabus, maybe we'll see about it. Okay, it's very interesting. The IUPAC naming is very, very, very interesting. Okay, any questions anybody has? People? So next class we'll be starting with periodic table. Okay, we'll be starting with periodic table. All right. Fine. Fine. If there are no questions, I think we can stop right here, people. Fine. I'm going to stop sharing, and then you can leave. Right. Thank you so much. We'll meet again next week. I'm going to end the
Thank you.
class.
Thank you.
Thank you.
Thank you, sir.
Yes, Kana. Thank you. Thank you.